In this video, the learner will draw orthographic and isometric representations and nets of three-dimensional figures. First, let's talk about what isometric and orthographic mean. An isometric drawing shows a corner view of an object. So we have our three-dimensional object here, and we can look straight at this corner and see what that object looks like. Notice we're using what's called an isometric grid to draw that figure. So what we're going to do is we're going to make a copy of this on your isometric grid paper. So using my line tool, I'm going to now draw this figure. So I can see starting on one of the corners, I'm going to go 1, 2 spaces down. So 1, 2 spaces down. Then from that corner that I made, I'm going to go 2 spaces up. And that creates that outer corner at the bottom. Now I'm going to go 1 space up on that left-hand side. And I'm going to continue to do that to make those boxes. 1 space up, 1 space up, 1 space up. Now I'm going to connect the tops of those segments. And now I've created that side view of my figure. Now I've got to finish off the top. So I see starting at that corner that I'm going to go 2 spaces to the right, so 2 spaces to the right, and then back down to connect. So I can see this top is blank, but I need to connect those and make those cross. So make 2 down, 2 up, and there's my three-dimensional figure. Go ahead and practice that a couple more times. Now we notice here that we have part of it that is grayed out. If we look at our figure, we can look at this from different views. This shaded section is actually our front view. So wherever you see that shaded part, that's going to be the front. When we take a look at this corner, if this green is the front, that means that this side over here is the right side of that object. These 4 shapes on top are going to be the top of our figure. And then behind the object where we can't really see is going to be the left side of that figure. Now that we've talked about the different views, let's take a look at what an orthographic drawing is. An orthographic drawing just shows a straight view of an object. So looking at it directly from the top, or from the side, or from the front. So our object that we looked at before, this is our object, and we had our top view. Those were our blue shaded squares. Then we have our side views. So that right-hand side was our 2 pink squares. Our left-hand side was actually behind it, and I colored those blue. And then our front view was that green. And it was just 2 squares. So our orthographic views show us just a flat 2-dimensional version from one perspective. Our isometric view actually shows a corner view and shows us how that looks 3-dimensionally. Okay, I want you to take a second and try and draw this figure on your isometric grid. Once you've drawn that figure, you should have something that looks like this. Now let's identify the different views of this figure. So from the front, we'll have these 2 green that show, but then also this green one that shows. And that will be what we see from the front. From the right-hand side, we'll see these 2 blocks and then this top block up here. That's going to be from the right. From the left, from behind, we will see 2 blocks and then that top block. And then from the top, we'll see these 4 squares here. I want you guys to go ahead and draw the side views, the top view, and front view of that isometric drawing. So we had this isometric drawing. We have our top, our front, and our right, and then our left was behind. So the blue represents our top, pink represents the right, green represents the front, and then the left is behind where we can't see it. I also want you to answer the question, how many cubes make this isometric drawing? So how many blocks are in this figure? Go ahead and draw this isometric drawing. And draw the side, top, and front views of that. Then I also want you to answer the question for this one, how many cubes make up that figure represented in the isometric drawing? Now we're going to talk about a foundation drawing. This is a diagram of the foundation showing how many blocks are in each column. So we want to know which isometric drawing shows the view from the right front corner of the building represented by the base plan below. So the right front would be from this corner. We can see here, this would be a view from the right front. So this would be the front here, and then this would be to the right of it. Notice this one actually shows us the left front. This one is also from the right front view. So right now we've actually eliminated this middle right here, and we just have to decide whether it is number 1 or number 3. That's where our foundation comes in. We have to know how many are in each column. So we see from the front we have 1 block, 1 block, 1 block in that L shape in the front, and then 2 blocks, 1 block, 1 block. So this tells us the height in each column. So here we can say we have 1, then 2, and then 1. So I know that this does not match my foundation drawing. So I know that this is now eliminated as well. Let's take a look at this last one just to make sure. We can see from this one we have 1, 1, 1, and then 2, 1, 1. That matches our foundation drawing. So this figure here is the one that represents the front right corner of that building. Next, let's talk about three-dimensional figures. We have the net, which is a two-dimensional drawing of a three-dimensional object. It's like if we took this rectangular prism and opened it up and laid it flat. So if we just tore that box apart and laid it all connecting on the table or on the floor. A face of this object is going to be the polygons that form a three-dimensional object. So notice here in this rectangular prism, all of these rectangles would be considered faces of this rectangular prism. So we have 1, 2, 3, 4, and then the top and bottom make 5 and 6. So we have 6 faces in this rectangular prism. The bases will be 2 congruent parallel faces. So when we talk about what is considered a base for this rectangular prism, we could say the top and the bottom would be considered bases, but it said that they have to be 2 congruent parallel faces. So notice the left and right are also 2 congruent parallel faces. So we could consider the left and right to be bases. Then we would consider the rest to be what are called lateral faces. These are the faces that are not a base of the figure. So if we consider the left and the right are bases, the rest of those rectangles would be our lateral faces. Then we have what are called base edges and lateral edges. Those are going to be our line segments that connect those faces and bases together. So the base edges are the segments that form the bases. So if we consider our top and bottom to be the bases, all of the edges along the bases would be those base edges. The lateral edges are the segments that connect the bases. So let me highlight here. If we consider the top and the bottom to be our bases, these yellow highlighted segments would be our base edges. And the segments that connect those would be considered our lateral edges. So these green segments would be our lateral edges. And then a vertex, of course, is a corner of that object. So we can see we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. I want you to take a second and I want you to think about how you would draw a net that would form a cube and one that would not. So think about how many faces that would have and how you would have to connect them to make sure it forms a cube. In this example, if the net below is folded along the dotted lines, what type of figure would be formed? So if we were to fold this figure along those dotted lines, what would we create? In this example, draw two different nets that would produce the following three-dimensional figure. So consider we have some triangles here. We also have some rectangles. So draw that flat two-dimensional drawing of those faces that are connected. I also want you to consider in this prism, what shape is the base of this figure? Lastly, draw the solid that would be formed from the net below from two different perspectives. So this right here is the net drawing of this cube, and I want you to imagine folding it together and drawing it from two different perspectives. So perhaps the sun is on top. Then maybe the sun is on the left face. So maybe drawing that from those two perspectives. We'll talk about all of these examples in class.